In section 5.4, we'll be reviewing linear and exponential tables, and then we're going to dive into quadratic tables. So that will be your new item today, is evaluating quadratic tables and identifying the patterns. So first example, we're looking at our pattern 10 to 26 to 42. That's adding 16. Let's see if that works. 10 plus 16 plus 16. Yep. Plus 16 plus 16. So that'd be a 58 and a 74. I then can build my recursive and explicit. Recursive would be f of x equals f of x minus 1, and I put the pattern at the end, plus 16. The explicit f of x equals my slope, which is a positive 16, and then I'm going to use the second term, x minus 2 plus 26. You could have done x minus 1 plus 10, or you could have done x minus 3 plus 42. For a linear function, you can pick your point when you use point slope form. So this would be identified as arithmetic, which you can also call linear. They go together. Okay, question B. Let's look for a pattern. 1 to 3, 5, 6, 7, 8, 9. That's adding 2. And it's all filled in, so I don't have to fill in anything. Recursive would be f of x equals f of x minus 1, and then at the end I put my plus 2 for my pattern. My explicit, it's adding, so f of x equals, it's adding 2 each time, that's my slope. And then I pick a point. I'm going to use 3 and 11. X minus 3 and a positive 11. This one is adding, so it would be called arithmetic or linear. They make a line. Question C. Let's look at its pattern. 1/2 to 1, 2, 4, 8. That pattern is changing. If I do adding, it'd be like add a half, add 1, add 2, add 4. It's not a consistent addition property. So it is actually multiplying by 2. And I don't have to fill anything in. Recursive, f of x equals f of x minus 1. It is multiplying, so I put a little dot by 2. Explicit, this one's a little different. I'm going to pick one of the numbers on my right side, and I'm going to pick a 4. If I pick 4, if I start with 4, my pattern is times by 2, then my power for x in the x column would have to go back one step because I started on the first. So to get back to 0, I'd have to go back a step. This is called geometric or exponential. Geometric and exponential will pair up. They'll both represent whenever you have that exponential, when you're multiplying or dividing. Question D, 64, 32, 16, that's cutting it in half. So 16 cut in half is 8, 8 cut in half is 4. So for my recursive, I would write f of x equals f of x minus 1 times by 1/2. Explicit f of x equals, which point do I want to use? Let's just use 1 and 64. Okay, I start with 64. I then cut it in half, and my power is an x with a minus 1. When I am dividing, it is called geometric or exponential. All right, now we're to the fun ones. Okay, we are looking for a pattern, and 0 to -5, that'd be -5, then 5, 6, 7, 8, -3, then that'd be -1, then that'd be +1. Okay, so my addition's moving, it's not multiplying by a number. So this one's going to be quadratic. Whenever you have a quadratic, you need to extend out your lines. Okay, you need 2. So this is going to be the first difference, and this is going to be the second difference. Okay, this might look a little weird at first, but I promise it's not that bad. So 0 to -5 is -5. 0 minus 5 is -5. -5 minus 5, 6, 7, 8, 3 gets you to -8. -8 minus 1 gets you to -9. -9 then goes back up, so then that'd be +1. -9 plus 1 is -8. So it kind of hops. 0 minus 5. Whoops, that was not it. 0 minus 5. Boom. -3. -1. +1. So it kind of like zigzags through. Now, if you notice, -5 to -3, that's adding 2. Adding 2. Adding 2. So this whole column here, +2, +2. Which means this would be -3, -5, -7. You can fill in gaps. Okay, so I want to know where -5, 4, 3, 2, 1, 0 would be right here. I need the 0 for the y-intercept. Okay, so I have to put a 0 on there because my table does not have one, which means if I have a +1 here 1 plus 2 makes a plus 3. So 8, 7, 6, 5. This would be a minus 5 right there. Okay, the table is all filled out. That is the most difficult part. For quadratic, the recursive, you are not required to learn this for the test. So we are going to skip. So whenever you have a quadratic and it's on your assignment and it gives you a box for recursive and explicit, you just leave it blank on your assignment, submit it, and you'll still get full credit. So just quadratic, skip the recursive. Explicit. In this lesson, we're only going to go over finding a and b. The explicit will be f of x equals ax squared plus bx plus c. So when I fill this in, f of x equals, I'm going to show you how to find a, and I'm going to show you how to find c today. That's our main goal, find a and c. So if I'm looking for a, I take the second difference and I'm going to cut it in half. So 2 cut in half is a 1. That's a. Then to find c, c is the y-intercept of your quadratic equation, right, where 0 is. That's why we had to go back that step. So right here, I'm going to place minus 5. Okay. On your assignment, you'll type in f of x equals 1x squared plus the letter b, x minus 5. Leave the recursive blank and submit it. On this practice, you are just learning how to find a and c in the quadratic explicit function. Okay, let's try b. 1, 6, 17, that's changing pattern. So I'm going to extend my table out. And we have the first difference, the second. Okay. 1 plus 5 is 6. 6 plus 11 is 17. 17 plus 17 is 34. Okay, so 5, 6, 7, 8, 9, 10, 11. That's adding 6, adding 6, adding 6 each time. So then 17, 18, 19, 20, 5 going backwards, 5 minus 6, that'd be negative 1. Okay, and then we need the 0. Got it. It's already on the table. We love it when they have it on our table for us. That makes it much easier. Okay, from there, we would have recursive, skip. Do not worry about filling it in. Explicit, f of x equals a x squared plus bx plus a c at the end. We're going to grab the second difference, cut it in half, half of 6. Half of 6 is 3. And then we need our y-intercept at the end. So here's our y-intercept. This is going to be a long line. And it's a positive 1, so I'm going to put plus 1. Okay. We have our changing pattern. Extend our table out. First, second, difference. Okay, and we're going to do 2 to negative 2 is minus 4. Negative 2 to positive 4, that's plus 6. 4 to 20, that's plus 16. 6 to 16, that's adding 10 each time. Sometimes it helps to just fill in the second difference once you find that same pattern. Okay. 16 plus 10, 26, negative 14. If I go back 10. And I have my 0. Perfect. I have 0, which was needed. So I don't have to add it to my table, it's already there. We then write recursive. It's a quadratic. We get to skip it. Explicit. F of x equals ax squared plus bx plus c. And I'm going to fill in those values. So a, cut it in half. 10 cut in half is a positive 5. And the y-intercept is right here. It's a positive 2. Plus 2. And our last example, 2, 3, 5, 8. Okay, yep. Also changing patterns when we add. Oh, and it's gonna make us fill in the blanks. That'll be fun. Okay, first, second, difference, and 0 would be right here. And we need a 0 on our table, and they didn't give it to us, so we'll have to fill a number in right here. All right, 2 to 3 is plus 1, plus 2, 5, plus 3, plus 4, plus 5. So then this would be plus 0, and it's going up by 1 each time. Okay. That's not bad. 8 plus 4, 8, 9, 10, 11, 12. 12 plus 5, 17. If I go backwards, minus 5, minus 4, minus 3, minus 2, minus 1, minus 0. That would just be a 2 again. 2 plus 0 is a 2. All right, we have everything filled in. The table, recursive for a quadratic. We skip. And then the explicit. F of x equals ax squared plus bx plus c. And we take our second difference, cut it in half. 1 cut in half is 1/2. And our y-intercept is a positive 2. Plus 2. Okay, if you write the explicit as f of x equals 0.5x squared plus bx plus 2, it is the same thing. totally fine to use a decimal instead of a fraction. For example 3, we are creating our recursive and explicit equation to represent the image below. On your assignment, I know that sometimes it's hard to like draw in your own table all the time. So I have this scratch paper and it has the tables blank. Okay, so while you're working and building quadratic functions and on your test, if you want to use these pre-built tables, please use the scratch paper. It's very helpful, and I'm going to show you how I would use it. So I'm going to take my scratch, and then based off of my screen, or the problem that they provide on the screen, I'm going to fill this in. So my first figure, I'm going to put my 1 here, has one block. My second figure has 1, 2, 3 blocks. My third figure has 1, 2, 3, 4, 5, 6. And my fourth figure has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The reason I left a blank here is because I need my 0. Oh. There we go. Okay, so these pre-built tables just make it so I don't have to draw a bunch of lines. We then fill in the first difference. So 1 to 3, that'd be plus 2. 3 to 6, plus 2. 6 to 10, wait, plus 3, sorry, 3 plus 3 is 6. And then 6, 7, 8, 9, 10, that'd be plus 4. So then 4, 3, 2, that'd be plus 1, plus 0. And the second difference is going up by 1 each step. And then that would mean this would be a 0. 0 plus 1 is 1. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. Okay. Our table is filled in. We then will create our functions. So recursive, this is a quadratic, so we get to skip. Explicit, f of x equals ax squared plus bx plus c. This is where I only need to fill in a and c for this section. Our next lesson will go over filling in b. So I take my second difference and I cut it in half. 1 cut in half, 1 half. Then I need my y-intercept. Y-intercept is a 0, so I can put plus 0, or I can leave it off because 0 is not really it's not gonna do anything, so. And there is our function. And if you do not like fractions, remember it's totally fine to write it as a decimal. So you may pick. You may write a fraction or a decimal. And these patterns, when the pattern is changing in your table, it is called a quadratic function.